Hello, everyone, and welcome to the June 16th Professional VMware.com vBrownbag Google Cloud Platform Series. We're here tonight with Sandeep Dinesh, who's going to be talking to us about Cloud Datastore. Sandeep, how's it going?
Good. How are you?
Doing great. So you were at another event today, you said? What were you
Yeah,
doing?
so I just came back from Google Cloud Next. We're doing events all over the world. I think we just did New York and San Francisco, and we're going to do London, Amsterdam, and Tokyo coming up soon.
Awesome. That sounds cool. A few show notes before we get started. For folks listening in, if you've got questions, you can drop them in the GoToMeeting chat or Q&A window, or you can drop a tweet with the vBrownbag hashtag, and I'll get those into Sandeep. You can catch our other shows, professionalvmware.com/brownbags. We've got Tech Talk signups for VMworld that are open now, so if you've got a session you want to do or you just want to share some knowledge, you can sign up at professionalvmware.com. We've got our Tuesday Google Cloud Platform series going on for the next 3 weeks through roughly July or so. Our APAC shows every other Thursday, EMEA every Tuesday, Latin America shows on Thursdays, and our US shows on Wednesdays. MIA folks are looking for VCP6 Cloud presenters, so if you've taken that or you're studying for that and you want to share on a section or an objective, let either myself or Greg Robertson know. And we're also looking for presenters for the VCP6 Data Center series that will kick off in July or so as well. You can grab previous shows if you're an iTunes fan, bit.ly/brownbag iTunes, and for all the other podcast players out there, bit.ly/brownbag podcast. If you've got questions for Sandeep, you can hit him up on Twitter at Sandeep Dinesh, or you can hit me at J Frappier. And with that, I am going to make you presenter. That's not the button I
Okay,
want, though.
cool. All
And
right,
that
so now I
should
got to
be over to
use.
you now.
All right, so are you seeing two screens or one?
I am seeing an elephant.
Okay, that is wrong. Let me fix that. Better?
Not yet. I don't know if it's me or refresh. Google Cloud Datastore.
Yes, perfect. All right, let's start. All right, so John, thanks for having me online. So today we want to talk about Google Cloud Datastore and what it is and how can you use it. So before we get started, a little bit about me. I'm a developer advocate at Google for the Cloud Platform team. I consider myself a full-stack web developer. Since I was a little kid, I've been hacking away on websites and things like that, and just figured out how to build all of it myself because I've had to. Before Google, I worked at an IoT startup that I founded. We're doing irrigation control for agriculture, and we're doing processing in the cloud for predictive analysis. So that's kind of my intro to cloud started then. Like Jonathan said, you can hit me up on Twitter at Sandeep Dinesh. Here's my GitHub and my email if you want to go old school. So before I get started and talk a lot about Datastore, I want to talk about databases in general, right? So we have Datastore, NoSQL databases, RDBMSs, and graph databases, and all these different types. So, what should you use, and how are they all different? So when I think database, the first thing that comes to my mind is SQL. And I think that's the first thing that comes to a lot of people. And so how about SQL, right? Why don't we just use SQL for everything? And the truth is, they store relational data really well. They support very complex queries like joins and unions and things like that. And they have a great track record, right? SQL servers have been running in production for years and years and years and have been running well. So why don't we use them for everything, right? So they do have some drawbacks. One is scale. It's somewhat difficult to scale a SQL server up. It requires a lot of maintenance and a lot of hands-on work to really scale it up to a cloud giant infrastructure-based project. And the other one is flexibility, right? With a schema, you are locked into a certain type of data structure unless you do a schema migration, which is painful at times. So you do have a lot of positive parts about SQL, and you do have a few negatives, right? So then came along NoSQL databases. And NoSQL databases is really a general term, right? There's so many things that are just categorized as NoSQL. So let's take a look at a few examples. So first we have like document stores, right? Something like MongoDB or CouchDB. It's a good example of a document store. And usually you're storing like denormalized data that is in a good collection together, and it really works great for a lot of applications. But again, it is sometimes hard to scale these databases out, and you still have to worry about replication and concurrency and things like that when you start scaling them out, right? If your database dies, do you have a backup and things like that? Then we have, graph databases, and these are a little bit more esoteric and out there, something like Neo4j or Stardog, and these are really good for extremely complex relationship mapping, right? Think like your Facebook friend network and all that kind of stuff. It's really stored well in a graph. And these usually have special query languages like Sparkle and things like that. And they're pretty niche, right? They're really good for certain types of data mining and certain types of relationship management. But in general, they're usually really slow. And honestly, they're usually built on top of SQL or NoSQL databases that pre-exist today. Key value stores are also a very common type of NoSQL database. So like Redis or Aerospike, right? And these are usually a little bit more simplistic. You have a key and a value. You don't really have structure or queries. But for that trade-off, you get really good scalability and really good speed, right? They're really fast and scalable horizontally. But you do kind of lose that queryable action. And finally, another category is distributed databases, right? Like Apache HBase or Cassandra. And these are usually based off of a paper that Google released actually way back when about Bigtable and things like that. And Apache HBase is the open source version of Google Bigtable, right? So it's really based on that kind of distributed technology, column-based architecture. So these are a bunch of NoSQL databases, and they all have their pros and cons. And honestly, you can use any type of database to serve any purpose. It just matters how much of a headache you want or don't want, right? Some work better in some cases, and some work better in others. So what is Datastore, and how does it fit into that spectrum, right? And why should you care about it? So first I want to give you a little bit of background about why we actually built Datastore and why we're offering it as part of Google Cloud Platform. So Google Cloud Platform really started with something called Google App Engine a long time ago, right? A few years ago. So Google App Engine, for those of you who don't know or have never used Google App Engine, and Terry, one of my coworkers, gave a great introduction to this in one of the Brownbag sessions before. So Google App Engine is basically a platform as a service. And what this means is you write your code, and depending on how much load you're getting on your service or your website, we will automatically scale it up for you, up and down for you, depending on what demand you get, right? So now we have this platform that can scale to infinity and beyond, right? And does it really well. But if you can't store data that scales just as well as App Engine, it's pretty much useless to have this front end, right? If you have, say, a SQL database running on a single VM, and you're pinging it with thousands and thousands of instances, well, that database is not going to keep up. It doesn't matter how many front-end instances you have if your database can't keep up. So we thought about it, and we built something called Google Datastore, Google Cloud Datastore, right? And what Datastore is it's really a database that's meant to keep up with App Engine. And the best way to use Datastore today is to use it with App Engine because they work so well together. But what happened is we pretty much created a database that could scale indefinitely and would never fail on you, right? Which is perfect for a lot of other things, not just App Engine. So that's why in recent years we actually opened up Datastore to be used as a standalone product. And internally, Datastore is built on Google Bigtable, right? Which powers pretty much everything at Google, from Gmail to Maps to Drive. Pretty much everything at Google is powered in the same technology that powers Datastore. Okay, so what does Datastore kind of give you, right? When you're building an application, you're using a database, these are the things you don't want to worry about. scale, performance, availability, sharding, replication, etc., right? These are things that are scary and you would rather not think about, right? And for a lot of people, when you're building your application, these are things that you don't really think about, and then it bites you down the line. So what Datastore does is it takes away these issues from your mind and puts it on us, right? We worry about these things, so you don't have to. So in a mouthful of cloud buzzwords, right? Datastore is a fully managed, NoSQL ACID database that's built for scale, high replication, and high availability. So what does that all mean? So it's fully managed, right? So Google's DBAs and SREs are your DBAs and SREs. You don't have to worry about software upgrades and patches and things like that and worry about the system going down. We have a really high uptime that you can look on the website. I think it's 99.9999. It could be higher, I'm not sure, or lower. And there's like, it just works, right? It just works when you need it to work. There's no worrying about it. It's also NoSQL, right? So that's kind of the major category it fits in. It's semi-structured data. So the data is structured, but you can change that schema on the fly. You don't have to remake your tables. It's also really easy to use, and I'll show you some coding examples later on. And it still has very powerful query abilities. So even though it's NoSQL, we still get a lot of SQL-like querying ability, which is really useful. Now ACID, right? What does ACID mean? So ACID really means that it's that's kind of an old SQL term to when you're talking about data integrity, right? So A is atomic transactions. This means that if you write something to Datastore, it's going to either completely write or completely fail. You're never going to have data that's written in a half-written state, right? You're never going to have junk in the Datastore. It's either going to completely succeed or completely fail and return an error message. And this allows you to really retry correctly, right? So you know you should retry the whole thing again and get it to work. And then it's consistent. And I put eventual in brackets, and I'll talk more about that soon. Basically, wherever you're accessing the data from Datastore, you're going to get the same results, which is very useful, right? You don't want some of your databases out of sync with others. And of course, it's reliable. Because we're managing all of it for you, you get that reliability. So now we have built for scale, right? So what does that mean? We always talk about Google scale. And it really is built for Google scale, right? And if you're not at Google scale, that's fine. It'll still work for you. But if you are at Google scale, it'll work for you as well. And that means thousands and hundreds and millions of people hitting your database, and it'll still work. And I wrote down scalable design by design, and that's because I really believe that Datastore, how it works, it really forces you to think in a way to ensure scalability from the start, right? While something like SQL and other NoSQL databases, you can get away with a lot of things that won't scale in the future. But Datastore makes it really simple to build scalably from the beginning, so you don't run into these problems in the end. And there's a 99 number, so it's 99.95 uptime. And I said asteroid proof, and what we mean by that is we do replication of your data, right? So your data is actually replicated in multiple data centers. So if an asteroid hits one of them, you're still okay. Your data is still safe. I think we have a little bit more of an issue with the worldwide catastrophe of an asteroid hitting a data center, but your data is safe. Okay, so I talked a lot about what Datastore gives you, so let's take a look at how to actually use it. So some quick terminology before we get started, right? In my opinion, the easiest way to think about Datastore is just to think about the same things you'd use in a normal SQL database, right? So in a SQL database, you'd have a table. In Datastore, we call this a kind, right? So they're almost the same thing. Again, in a SQL database, you'd have rows of data. In Datastore, we call these entities. And then SQL database, you'd have primary keys to identify this row. And in Datastore, we just call this a key. And then each individual piece of data inside that entity or object, in SQL we call that fields, and in Datastore we call that a property. So it's pretty much a one-to-one mapping between the two, so it's very easy to understand. Okay, so let's look at a quick example of this terminology, right? So let's say we have an employees table. In Datastore, we'd call that a kind, right? So we have an employees kind. Now, let's say we have these rows of employees, right? Again, in Datastore, this would be called an entity. Now, in each employee, each one has an employee ID, right? So this would be something like a key, right? So the ID would be like a key. In SQL, again, it'll be a primary key. And then we have the fields, right? And in Datastore, these are called properties. So you can see how it's pretty easy to build up this infrastructure. Okay. So now I promised to talk about eventual consistency versus strong consistency, right? And what's the difference and what do they mean? So first, I want to talk about eventual consistency. Now, eventual consistency sounds scary, but it's really not. And I have a quick example to explain what exactly this is. So let's say that we have two data centers, right? And of course, we have a lot more than two, but let's just say we have two. And we have data center 1, data center 2, and we have 3 users. Now, user 1 and 2 connect to data center 1, and user 3 connects to data center 2. So let's say that user 1 is going to write some new data into the data center 1, okay? And so he hits one of the nodes, and it gets the new data, and almost instantly, the data is replicated throughout the data center, right? We have great fiber links between all our nodes, so it's really, really fast. So the data gets replicated quickly. Now, let's say user 2 and user 3, almost right after user 1 writes that data, they want to read, right? Because user 2 is reading from data center 1, she'll get that new data. But user 3, he might be reading from data center 2, and it hasn't replicated over, so he'll get that old data. And then eventually, it'll replicate over, and user 3 will receive the new data, right? So eventually, everyone gets the update. It just takes a little bit of time. And then on the other hand, we have strong consistency. Same example, right? Data center 1 and 2, and again, the same 3 users. When user 1 writes it new data, it hits the node, it gets replicated across, and then user 2 and 3 try to read. But one way of doing strong consistency, right, is to lock the reads. And you lock the reads and you wait until all the data is replicated through, and then you push everyone gets the new data. So now it's strongly consistent. Everyone sees the same picture at the same time always. And there's reasons why you'd want to have things strongly consistent and why you want to have things that are eventually consistent, and I'll talk more about that later. And what I want to do right now is explain how Datastore does strong consistency. So in Datastore, we have a concept called entity groups. And if you remember, entities are like rows in a database, right? So we basically group these rows into groups, right? So we have a table with multiple groups inside. And we do this grouping using something called ancestor keys. So an ancestor key is like an ancestor for a group, right? And the ancestor can be an entity of any type, right? It doesn't have to be the same type. Usually it's not, right? So you'd have maybe one type is an ancestor for a group of another type. And what does this give you? So when you have an entity group, basically when you query that entity group, so let's say like select from entity group, right? So you say where ancestor key equals blank. When you do something like that, all the results are going to be strongly consistent because you're querying that specific entity group. And what this does is it allows you to do that strongly consistent query. But there are some limitations, right? In order to ensure the strong consistency, we limit the number of writes. So in that example I just showed, we limited reads. In Datastore, we limit writes to, I think, 1 per second, right? So you can only write 1 per second to each entity group, but you can read as many times as you want. And I'll get into a little, like I said, I'll get into an example of when we should use what and what the consequences are. So quickly, let's look at some common types of queries and what type of consistency they are. So we have global queries, right? So this would be something like select star from table, right? Or select star from table where name equals Mark. And this is eventually consistent because we're querying the whole table, we're querying the whole entity type, right? And we're not sure exactly which data center has the latest data. And then we have key queries. So key query is like, get me employee number 12345, right? We know exactly which employee we're looking for, and so that is going to be strongly consistent. We know exactly where to look in which data center to get the data from, and we can keep that strongly consistent. And then we have ancestor queries, like I mentioned before, right? So this is where, let's say we have our entity groups are based on department. So if I say, get me all employees named Mark who work in accounting, again, this would be strongly consistent. Okay. So let's look at a quick scenario that I came up with explaining consistency. Let's say that you're a IT admin for a laboratory, right? And your company has labs across the world, like thousands of laboratories. And you want to log everyone who goes in and goes out for safety reasons, right? You want to know if there's a fire somewhere, you know exactly who's in the lab, dealing with what chemicals, things like that. So in your log, you basically have an ID, a name, a time, and what they're doing in the lab, right? Basic stuff. And now you have an emergency, right? A fire has occurred in a lab. And we need to know exactly who's in each and every lab and figure out what's going on, right? So how would we do this with Datastore? So one way of doing it is make the whole thing strongly consistent, right? Put all 1,000 labs in the same entity group. Now, when you do a query, it's going to be strongly consistent, so we're good to go. But the problem with doing something like this really is that 1 write per second limit, right? If you're limited to 1 write per second, you have thousands of labs around the world, then people are have to queue up in a line and wait to get in, right? So the log can write, and then wait to get out so the logs can write. That's not a really good user experience. You can take this example and really scale it up to something like a website, right? If it just sits there and starts loading and loading and loading for seconds and seconds and seconds before the page shows because it's waiting for this write to happen, it's a bad user experience. So what's the solution? What you could do is have every lab be the ancestor for its logs, right? So all the entities are grouped by lab. And now when you have an emergency, you simply write a program that asks each lab, hey, is your lab empty? 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 Right? And we go through each and every lab, and we just loop through them, and we get strongly consistent results, right? And we aggregate all of these results together to take an action. And then for our normal queries, right? Let's say we have a dashboard that shows the average lab utilization, or maybe the number of people who are in a lab, and we're having this query run live, right? Because this is a global query that's eventually consistent, it runs really fast, and we're not limited in any way. So the key takeaway that I kind of want to explain is Datastore gives you eventual and strong consistency, and it's really up to you to decide when you want what, right? And usually it's pretty natural to understand when something is applicable. So yeah, you have the option of choosing one or the other. All right, so that's enough of me just talking and talking and talking. Let's get into some code and see how you actually use Datastore. So APIs, right? How do we access Datastore? So we have JSON and protobuf APIs if you want raw level access, right? These are just over a normal REST or protobuf protocol that you can use with any language. But of course, we have something called the GCloud Library. And these are idiomatic and open source libraries for languages like Java, Ruby, Python, Node.js, and Go. And so this is what I'm going to use. I'm going to be writing in Python, and I'm going to show you how to actually use Datastore. So just example here, all my code is available in this GitHub, and all code I'm going to write is copyright Google and licensed under Apache version 2. I just got to throw that out there. That means you can use it in your stuff. There's no problem. It's Apache 2, so it's open source. Okay, so the first thing we need to do is pip install GCloud, right? So it's just Python installing the GCloud library. And now I'm going to go into my terminal that I don't have running. All right. Let's see where I am. So I'm going to go into my directory. All right. So here I have a demo that I pre-scripted, and we'll just walk through it. So, okay. Some license stuff. So first, we're going to import that library in. And if you've never used Python before, don't worry. I'll explain everything as I go along, so it's very clear. And again, like I said, you can write this in Java, you can write this in Ruby, you can write this in Go, Node.js, things like that, or just use the straight REST API. So we're going to import the Datastore component. We're going to import some things to read things from the OS and the time. And here, what we're going to do is set up some environment variables, right? So I'm going to say, get this key.json, and I'll explain what that is right now. So in our Google Developer Console, and this is console.developers.google.com, what you can do is authenticate third-party applications. So say an application running on your servers or your on-prem instance or whatever you have, right? What you do is you go into the credentials section, and we can just generate a JSON key here, or we can create a new client ID. Let's say it's a installed application, right? It runs, a service account. This basically runs on a server of some sort, and we hit create client ID. And I actually have a few slides on this. Let me just show that. Right here, so we create a project. We go to APIs section. We enable the Google Cloud Datastore API. Again, we go to the credentials, create a new client ID, choose a service account, and click Create Client ID, right? So these are the steps we need to actually spin up a Google Cloud project and get that token that we can use to authenticate from our own machine. So now we have all this stuff, right? We can get started. So if we look back here, let's click Cancel. I'll go to my overview, and I'll see that my project ID is Mythical Geode 93517, right? So back to my code. I downloaded that key.json. It's in this directory, so I'm just going to say Google application credentials equals that key.json. My project ID is Mythical Geode 93517. I'm going to set the project ID to that project ID. My dataset ID to that. That's a default dataset that I'm using. And then do a datastore.set default dataset ID again to that project ID, right? And you can have multiple datasets in a project. I'm just going to default to the standard kind of project ID. All right. So that's the whole setup. Now we can actually connect to Datastore and start doing stuff with it. So what I want to do is kind of build a message board or a news website and kind of walk through how I'm going to do that. So first, I'm going to create a fake email for our fake user, right? So I'm going to say email equals me@fake.com. Okay. So now let's create a key for that user using that email, right? So remember, a key is that unique identifier for an object or an entity in the Datastore. So what I'm going to do is say user key equals a new datastore.key, and then here we have something called user, right? And this is the kind, right? So this is the table, right? So user is the kind of object I'm creating, and the unique identifier is the email, me@fake.com. Okay, so let's print that out. So you can see that we have our data set equals Mythical Geode 93517. It's pulling it from the default up here. The kind is user, and the name, which is the unique identifier, is me at fake.com. Okay, so now let's create an entity using that key. Again, an entity is like a row in a database, right? So all I'm going to do is say new user equals datastore.entity, and then make the key equal to that user key that we created. All right. So now you can see that we have an entity. Here's the key information, and it's empty, right? We haven't added any data to this entity. So let's add some fields to that entity. All right, cool. So I'm going to say the new user name equals I am a fake. I'm using Python 2.7, so Datastore likes Unicode strings, so I'm just going to wrap everything in Unicode. That's all it's doing is converting a Python string to a Unicode string. I'm going to set the email, and let's print it out. So now, again, we have the entity, right? The key is right here, and now we can see that we just have that information in a Python dictionary, which is a very Python way of doing things. In every single language, like Go, it'll be a struct and things like that. Okay, so now we have this entity, but it's just sitting in memory, right? It's just sitting in Python right now. So let's actually push this entry to Cloud Datastore. And how we do that, we just go datastore.put new user. And bam, it's pushed into Datastore. And we can actually go to our Cloud Console again and view this information. So I'm going to go down here into the storage section, and then go into Cloud Datastore, and then go into Query. So you can see here I have a user, right, and me at fake.com, I'm a fake, the email, everything is there. So we actually pushed it into our Datastore online in the cloud. Okay, so let's actually get that user and print it on our program. All we have to do is do a datastore.get and give the key. So this is one of the key queries I was talking about, right? So this is a strongly consistent query because we know exactly what we're querying. We're using a key to get it from the data store. Bam. So actually we went to data store and pulled it down, and here we go. It's the same object, of course. You can see that it kind of shuffles these around because it's Python and dictionaries are not consistent in that way. They shuffle the order around a lot. Okay. So now now we have a user, great. Let's write a story, right? Let's publish a story to our blog or our newsboard or our website, what have you. And what I want to do is make something called an incomplete key. And all an incomplete key is we don't have a unique identifier for it, right? For a story, we might think, oh, we can use the URL for a unique identifier. But you might post google.com once and then google.com in 2 years, and the homepage might have changed. Maybe there's a little Android on it or something. And it's changed, right? So you don't want to use something like the URL for a unique ID. Instead, we're going to actually have Datastore make a unique ID for us. So let's see how to do that. So here we have story key. We're going to call it datastore.key. Again, same thing. The kind is a story instead of user, right? And you might notice that I'm not giving it any sort of unique identifier. And then I'm going to make a new story and say it's a datastore.entity. The key is a story key. It's the exact same thing as I did for the new user. All right. So now let's add some fields to that new story. I'm going to give it a URL, a title, some text, and a timestamp, right? So this is like a normal thing, like a blog post or a story that you're posting to a website like Reddit. These are like the kind of things you'd have for each story. All right, so let's print it out. And here we go. So here's our new story that's been created. You'll notice here the kind is story. There's no unique identifier. And then here's all the data that we're going to push. So now let's actually push that. Again, it's just a datastore.put. And we're going to put that new story into the cloud, right? And we can go here and check it out. So let's refresh this page. Here we go. So we have users and stories. If I query all my stories, you can see the stuff we just put in. And you might notice that we got this ID, right? And so Datastore automatically made this unique identifier for this story.
But I mean,
okay.
If you were like an addressable part of the conversation.
Okay, so now we don't really know what the unique identifier is at this point, right? So if we try to do a data store.get and give it a key, it'll actually crash because it'll say there's no unique identifier. Instead of doing a get, what we can do is a query, right? We can do a global query that's eventually consistent and pull all this data in. So get every single story that we have. So what I'm going to do is do query equals datastore.query. The kind is a story, right? So this is like a where clause in SQL. Sorry, not a where clause, a from clause in SQL, right? So from this table. So kind equals story. And then I'm going to say order. I'm going to order by negative timestamp, right? So I want the latest stories first. All right. And then to run the query, all I have to do is do a query.fetch. It returns an iterator in Python, so I'm going to turn that iterator into a list so I can print it out. That's all I'm doing with the list function. And let's print out the results. So here we go. So we queried it, and we got the entity back from the cloud. Yep, and it all checks out. And you might notice here that we get this unique identifier back, right? In here, we did not have that unique identifier. That's because we hadn't pushed it to data store yet. Now that we have, data store can actually make that unique ID and give it back to us. All right, so let's make another story. I'm going to go through this quickly. New story, entity, give it a key, give it another URL. Here's my blog. Interesting blog. Great. And give it a timestamp. We're going to put it into our data store. Boom. Okay, so now we have two stories, right? So let's reload this page. And if we check it out, you can see that we have two stories in our database. And if we run the same query again, right? So I don't have to type my query. I can do another query.fetch and list it out. Let's print it out. Here we go. So now I have my first story and my second story, right? And because it's ordered by timestamp, if you remember here, we were doing it by negative timestamp, we get the latest story first, right? Okay, so cool. Now we have stories. That's great. Now, typically, in this kind of thing, you want to give comments, right? Like, hey, this story sucks. Hey, this story's cool. Have you ever heard about cats? I don't know. Cats are very popular on the internet. So let's add a comment to the first story. So the first thing I want to do is actually get that ID, right? Get this unique ID from that story. And I already have everything stored in this results, right? I already did my query and I fetched it and I stored it in results. So now I want to get this ID. So I'm going to say the story equals results sub 0, right? The first in the array. And then what I'm going to do is say story ID equals story.key.id or name, right? So story is this huge entity right here. .key will give me this key right here. And then ID or name will give me this ID, right? Names are strings that we use to uniquely identify, and IDs are the automatically generated IDs. And ID or name will select whatever is appropriate. So here we go, and my story ID is 5649 blah 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 and 5649 blah blah blah, right? So it's this one right here. All right. So now let's look at how we can actually create that comment. Now we have that story ID. So what we want to do is create a new key, right? So I'm going to call this the comment key. And you might notice a new field I'm using here. So I'm going to say datastore.key. Again, the table or the kind is a comment. And I want to say the parent of this comment is the user, right? So when you're writing a comment, it's important to know who's actually writing that comment. So what I'm going to do is use the user as the parent for this comment. So I'm going to switch back to my slides real fast and explain why I'm doing this. So here's the architecture that I'm kind of building up, right? So we saw the users and we saw the stories. We saw that we have the user has an ID and a name, right? The ID is like email. And then we have stories. The ID is an auto-generated thing. The name, the URL, the text, things like that, right? The title, that's what we call the name here. Now we have these comments, right? And we have a decision to make. do we make the ancestor of the comment the story, or do we make the ancestor of the comment the user? And when you think about it, it really makes sense to make the ancestor the user. And this is the reason why. Let's say that you made the comment ancestor the story. Now, for each story, we're limited to 1 write per second, right? You can only write 1 comment to a story per second. And when you have a website like Reddit or Hacker News or something like that, that's really bad performance, right? People are going to be like waiting and be like, why is my comment not posting, and things like that. Bad experience. But what happens if you put the ancestor to the user? Now the user is limited to 1 comment per second, but that's completely reasonable, right? Only spammers would spam more than 1 comment per second. And more importantly, when the user wants to query his own comments, it's strongly consistent, right? So the user is always guaranteed that he's going to get his comments back, right? It's not that important that you see all the comments in real time. Let's say someone in Saudi Arabia posts a comment. It takes like 5 seconds for it to go across the world and come to my browser. That's okay, right? But if I post a comment and I hit refresh and the comment is not there, I'm going to be really confused. I'm going to be like, hey, I just spent like 5 minutes arguing with this guy on the internet, and I posted my comment, and I was about to win this argument, and it's not there. Well, it's there, but it's just not strongly consistent, so it's not coming up, right? So you might get angry and things like that. So it's really important that the user can see his or her comments immediately, right? So it makes a lot of sense to make the ancestor the user. And what we're going to do is just make the story ID a field in the comment so we can have that linkage, right? A soft linkage between the story and the comment. Okay, so back to the code. So here we go, here's our comment key. Now we're going to create that new comment. Again, just a datastore.entity, give it the key. Put some text in, cool story, bro. Now, like I said, we're going to store the story ID as a string and timestamp for that comment. Okay, so let's take a look. So we have this. You can see here that we have this kind user name me@fake.com. That's the parent of this entity. And then we have the key for that comment itself. Again, there's no unique identifier. Datastore will make one for us. And actually, before I forget, that's actually the recommended way of doing it, right? If you don't really have a unique identifier that's meaningful, it's way better to allow Datastore to make that unique identifier for you. It's not good to go like 1, 2, 3, 4, 5 for performance reasons, right? When Datastore is allowed to manage these unique IDs, we are able to scale your database a lot quicker and a lot better. So yeah, again, if you don't have unique IDs, let Datastore make one for you. And then here's our entity, cool story bro, timestamp, and our story ID, which is 56490. Again, 56490. Let's push it up. Just datastore.put, and bam. All right, so now if we go here and refresh, and refresh. Here we go. Here's our comment that came up, right? Cool story, bro. Okay, great. So now I'm going to get the story. I'm just going to push another comment to the other story, and I'm just going to go through that quickly. It's the exact same thing. I'm going to create another comment for the same user. Go through it. Print out. Here's our new comment. Again, if you look at the story ID, it's 57410, and if I scroll up, 57410 is the second. Let me check it out. Here we go. 57410. It's the second story that we have. So let's push it up. Again, it's just a datastore.put, and let's query for all the comments, right? So again, I'm going to do a globally consistent query. I'm going to get all the comments. So here we go. We have query equals datastore.query, kind is comment, order timestamp, right? I want the oldest one first in this case. Let's fetch them and print it out. All right, here we go. So we got our first comment and our second comment. And in a real system with thousands of people using it, with the eventual consistency, sometimes we'll miss all of them, right? When we do a query like this. But in this case, it's just me talking to a database, so we're easily able to replicate it across all our data centers. Okay, so now let's take a look at how to query for comments on a single story, right? Using that story ID to get the comments for just one story. And what I use is something called a filter, right? And a filter is just a triplet, so story ID equals story ID. And again, I'm ordering it by timestamp. Okay, so normally this query would actually fail because we're doing it this way. So if we were doing it with App Engine, it's a little bit different story, and I'll explain that in just 1 second. And it's going to fail because we don't have a joint index on story ID and timestamp, right? So if we're trying to do a filter that has multiple filters, right? So in this case, we're filtering by story ID, and all order is a special type of filter, right? So we're actually filtering on 2 different columns. And by default, every individual column is indexed, but when you want to have a query that's multi-column, you have to index them together, right? So let's take a look at the slides again. And this is what happens. If I ran this query normally, what I would get is I would get a precondition failed, no matching index found, right? So we need an index that's both on story ID and timestamp. And so what we need to do is use the GCD tool, or Google Cloud Datastore tool. It's a Java-based tool. You can download it here. And basically we do, we create a new application, right, create. We make index.xml file, and you can see basically I have Datastore index says, auto-generate equals true. Then I make a special index right here. I say kind is comment, ancestor is false. This is not an ancestor index, so I don't need it to be there. Property name, story ID, direction is ascending, property name timestamp, again, direction is ascending. And then I push this configuration up using the GCD tool, and then I get my index created, right? So this is my special index. You can see it's on story ID and timestamp. Okay, so I mentioned with App Engine you don't need to do this. And the way App Engine works, and this is why I really think Datastore really works great with App Engine, is when you're using App Engine as a local development server, and you're doing your local development, every query you hit will automatically make these indexes for you, right? So when we ran our query, we're going to run our query here, right? In App Engine, that index.xml file will automatically be generated and pushed when you deploy your App Engine code. Because we're using a raw version of Datastore, we have to actually make those indexes ourselves. So that's the only caveat there. So let's run that query, print it out, and I got nothing. So story, which is interesting. Let's refresh this. Anyway, so you can see here when I query by the story ID, we get that story back. I'm not sure why that didn't run, but maybe I just took too much time and something happened. Let's do another thing before I finish up with the demo. What we want to do is create an email, another user, right? So Mrs. Fake at fake.com. Let's create that entity, put it in the data store. Now I want to make a new comment for that user. Oh, this is a boring story, and I'm going to go ahead and put that new comment in. So now I have a new user who wrote a comment on the same story, right? So if I query again, let's see if it comes out this time. It's not coming out. So what you would normally see, and I'm not sure I debugged this, is you'd see that you get both results, right? You see the old comment from our first user and the comment from our new user. So that's great. So that's how those work. And now what we can do is try to get the ancestor key, right? So all the queries we saw before were eventually consistent queries. which means that there's a chance that you don't get all the data. But with the ancestor query, right, with the entity group, it is strongly consistent. So what we're going to do is say query equals datastore.query, give it the comment, and say ancestor equals our user key, right, our first original user. And let's query that, print it out. There we go. So now we get both comments that our user made. And that's basically it, right? So we saw creating objects in Datastore, querying those objects, using key queries to pull individual entities out when we have the unique identifier, and using ancestor queries to ensure strong consistency. And go back to my slides. And so that's basically it. Again, all this code is available on GitHub right now, so you can go test it out. And follow me on Twitter at Sandeep Dinesh. And that's it. I think, John, maybe we can look for questions now.
Yeah, all quiet on the question front. Thank you for presenting tonight.
No problem. Thanks for having me.
And thanks for the folks that were on with us live, and we'll have the recording up within the next couple of days. Thank you very much again, Sandeep, and have a good night, everyone.
All right. Good night.